Imagine a shopkeeper, let's call him Mario, working in the mushroom kingdom. If he wants to increase his daily income, the obvious first step seems to be simply raising the prices on his items. But in economics, whether a price increase actually generates more money depends entirely on how buyers react. We measure this reaction using the Price Elasticity of Demand, or PED. Before calculating elasticity, we start with a strict equation. Total revenue for a firm is exactly equal to the total expenditure of the consumers. It is calculated by multiplying the price of an item by the quantity sold. To understand how consumer behavior dictates pricing strategy, we need to translate that simple multiplication problem into a physical shape. This is a standard economic graph. We map the price of our items on the vertical axis and the quantity sold on the horizontal axis. When we plot a specific price and quantity coordinate, we can draw lines straight down to the axes. This forms a rectangle. Because the area of a rectangle is found by multiplying its height by its width, price times quantity, the total space inside this box represents our total revenue. Any change in revenue is just a change in the dimensions of this box. This diagram displays an inelastic demand curve. Notice the steep vertical slope in panel A. This tells us that consumers consider the item essential, so they will continue buying almost the same amount regardless of price hikes. Let's apply this to a necessity in Mario's shop, like a superstar. We draw our steep demand curve, select a starting coordinate, and shade in our initial revenue box. Watch what happens mechanically when we raise the price. The coordinate slides up the curve. The price increases significantly, but the quantity demanded barely drops. This creates a visual tug-of-war. We can separate the changing areas into two pieces, a green section at the top representing new coins gained from the higher price margin, and a thin red section on the side representing coins lost from the few canceled sales. Because the green gain box is visibly larger than the red loss box, raising prices on inelastic goods will reliably increase total revenue. Now it's your turn to apply the framework. Imagine a common item with many substitutes, like a standard mushroom. Draw a flat, shallow demand curve. If you raise the price, predict what happens to the revenue box. Pause the video and trace it out. Let's walk through the solution. We plot our starting coordinate on the flat curve, establishing our initial revenue box. When we push the price up just a little bit, the coordinate slides far to the left. The resulting drop in quantity sold is massive. Comparing the areas, we get a thin horizontal strip of green gains, entirely overshadowed by a massive wide block of red losses. We can verify this mathematically. Our starting box was $4 times 100 units for $400. After the price hike, we gain $70 on the units we still sell, but we lose $120 from the buyers who walked away. The new total falls to $350. When consumers have alternatives, they are highly sensitive to price. The lost sales wipe out any benefit from the higher margin. For highly elastic goods, a firm must lower prices to expand their revenue box. This exact geometric relationship also dictates government policy. Imagine Bowser needs to fund a public project using an indirect tax on consumer goods. To maximize the money he collects, he faces the same dilemma as our shopkeeper. Does he place the tax on an elastic market or an inelastic market? On an inelastic good, a tax wedge forces the price up. Buyers absorb the cost, keeping quantity steady, generating a massive rectangle of tax revenue. But on an elastic good, consumers stop buying. Quantity collapses, and the tax revenue rectangle shrinks to almost nothing. This geometry explains why governments consistently target highly inelastic goods, like fuel or essential imports, for indirect taxation. The lack of substitutes guarantees the tax revenue will be collected. Whether you are running a shop or an economy, elasticity dictates the outcome. When demand is elastic, price and revenue move in opposite directions. When demand is inelastic, price and revenue move together.